Assalamu alaikum. I welcome all of you to the course on advanced mass spectrometry. In the previous section or lecture, we discussed that why mass spectrometry, why we study mass spectrometry, and I mentioned some of its very important uses. So today what we will be studying the basic principle of mass spectrometry and other related things. So what actually is the basic principle of mass spectrometry? As again in some sort of normal words, the basic principle of mass spectrometry is to detect or to weight or to measure or the mass, atomic mass or molecular mass. So how it is possible? First of all, it's not possible to have a single atom, to get a single atom and place it on a detector. So there must be some way for it to, in order to separate a single atom and place it on a detector to detect it or to get its weight. So that is called a basic principle. So almost all mass spectrometers, they have some common things that are ionization source, that are just number first, ionization. This occurs. Then after that, separation. And the third thing is detection. Why ionization? Because I have written this. It is a compulsion, and it will be clear after some time that why ionization is important. And what thing will be doing the ionization? So ionization source. Ionization source will be doing the ionization. And separation, as you know that in lab we separate chemicals by means of filter paper, so it's a sort of a filter paper type of thing, but it's an instrument. It's called as an analyzer. Here for separation, what is used? Analyzer. And for detection, it's tantamount or analogous to what? Weighing balance. So some digital thing will be used, which will be called as the detector, that could weight a single ion. So the detector is a detector. I should not write anything else. So the main use of mass spectrometry is to measure the mass of a molecule or an atom. I'm not mentioning atomic weight deliberately, because it will be clear that why I'm saying that it just choose to give us mass. Which mass it is, it will be clear to you after some time. I cannot say that it will give us the atomic weight, okay? So because atomic weight is something else. And it is also, the mass spectrometry is also very much helpful in determining the structure of a compound. So it's another use of this mass spectrometry. The mass spectrometry is extremely sensitive technique. Sensitive in a sense, what sensitive is? Sensitive in a sense that it can detect a very small amount of a sample. So let me rephrase it. If we want to do this technique, a very small amount of the analyte is sufficient to carry out or bring us the spectra, or to carry out the analysis on the mass spectrometry. So the mass spectrometry can detect nanograms, or even it can detect below nanogram scale. So it is very sensitive. So sensitivity means, the word sensitivity means that the detection of a small amount. In instrumental terms, it means that a detection of a small amount. Just like we say that A dog is very much sensitive to smelling. A dog is very much sensitive to meat because it can smell it from very, very far away. So it has a great sensitivity for meat. If a small amount of meat is present somewhere, a dog can smell it and we can't. So dog is much more sensitive in sense of smelling. But for the information, what the mass spectrometry will give us, what will be its result? How would we know that it is giving us the mass? So it will give us a spectrum. What a spectrum is, what a mass spectrum is, it would be like this. M or Z, or here signal intensity. Now again, very, very difficult terminologies I am writing here. But what actually is M by Z, M or Z, M divided by Z. What is M? What is Z? And what is the signal intensity? Because it is just a two-dimensional spectra. Two-dimensional mean that it relates two things. It relates the masses with intensity. So let's come to the M by Z thing. So it is just a ratio of mass and charge. So when we think that what is mass and what is charge, so suddenly something come out to our mind that mass is always denoted in a kilogram, mass, kilogram, and the charge in a coulomb. But this will become extremely difficult. This thing will become extremely difficult to comprehend the spectra. And again, you will know a bit later or with the course. So the scientists, they devised another thing, alternative to this kilogram per coulomb. They just brought M by Z. What is M? M is the atomic mass. Suppose, what is atomic mass, or M could be an atomic mass or some molecular mass. Like if you have, let's say, lithium, its mass is, I think, it's 7. Suppose it has some charge on it. Lithium is 7, and if lithium has lithium plus 1, so what is it? Lithium ion, lithium plus 1 ion. So how can we write it in the M by Z sense? We can write it like M is equal to, lithium has a mass of 7, I think, and its charge is plus 1. So we can write it like M by Z, or 7 by 1 is equal to 7. So this mass spectrometry will give us a value of 7. In mass spectrum, the mass, so it's just like it gives us in most simple mass spectrum, or most simplest technique, the M by Z is just the mass. As you see that lithium mass was 7 and we obtained the result as a 7. What about the Z term? The Z or Z, it shows elementary charges. What are elementary charges and what does it mean? Just like now Z is a charge on the atom or ion or molecule. So it is, lithium has plus 1 charge. So its elementary charge is plus 1. So if you write it like this, so its M by Z will become 7 by plus 1 is equal to 7. So there is another thing. Now the spectrum has another thing, On the y-axis that was signal intensity. What actually is the signal intensity? Suppose it's just very simple, that how many molecules of which we are going to determine its mass can strike the detector or can sit on the detector. Just like if we had some lithium plus ion and it's just strike the detector. So what will happen? As its mass is 7, as you know from its m by z, 7 by 1 is equal to 7. So in mass spectrum, a value will appear. M over z. So the value of m by z increases this way, from left to the right. Now for 7, a line will appear or a peak will appear. If you just zoom it, it becomes a peak, but normally it's like a line in normal spectra. So a line will appear on m by z 7. So that's what the mass spectrometry does. So as I told you that the signals, so what does the signals tell us? The signal tells us the number of ions striking the detector. It will be clear by a small example. Suppose we have a mixture, a gas mixture of helium, which mass is 4, and neon, which mass is 10, and both are ions, plus 1 ions. So helium plus 1, so for it m by z is equal to 4 by 1 is equal to 4. And for neon, plus 1, m by z is equal to 20. 20 by 1 is equal to 20. So it will be 20. Let's suppose we have 100 molecules of helium plus 100 ions. Suppose we have 100 ions and we have about 20 ions of neon, or 10 ions, it will be 10 ions for neon. As the mass of neon is 20, we have 10 ions present, plus 1 ions. Suppose it has some plus 1 ions, because it is very difficult to ionize, but anyhow, it's an example for people to understand. If we have 10 neon ions and 100 or 100 helium ions, so how would its spectrum like if we have, because both of them are gases and we have a mixture of gases, we just kept both of them in some cylinder or a bottle and we just shake it and mix them, and now we want to determine its masses, we want to see its spectra, that what it gives us. So ionization, first suppose we really don't know how they are ionized as yet, because I haven't told anything about its ionization. So separation, again separation is another topic, it's analyzers, but we will be studying that later in the later cases. But first I want to give you a crude picture. Suppose helium ions, you have 100 ions of helium gas and 10 ions of neon gas. They are kept in a bottle, and both of them are just a mixture, and you want to analyze them on mass spectrometer. Which mass spectrometer you don't know right now, and I will tell you that. Suppose you want to you just put that in a mass spectrum. Both of them are present in this cylinder. Cylinder is closed, and you place this on mass spectrometer. Suppose somehow you put those gases in the mass spectrometer and it gave us result. So what will be its result? This is a pre-study, because we don't know, but just want to tell you that what it will give us M or G and signal intensity. Now let's move to the ions. Helium has 100 ions. You had 100 gas molecules ionized of helium and 10 ions of neon 20. Neon has mass of 20, helium has mass of 4, but you have 100 molecules of helium. Now for helium, a big peak will appear, about 100 molecule long peak, because if 100 molecules all manages to strike the detector, so this big signals will be given by the helium molecules. And now what about, and it will be present on 4, M by G4. M by G4 means ki helium plus 1, it is 4, and 4 divided by 1 is equal to 4. About the neon, you have 10 atoms. So neon will give us a peak at 20, because you have 10 atoms, so it will be 10 times smaller than helium 1. So that's how crudely you can say that mass spectrometer can determine the mass of the things, or the mass of atoms. In reality, things are quite different, and we are going to study that. So this is a very crude picture, that you had some helium and neon in a bottle mixture. You somehow ionized it and you passed it through some filter, and that separated them. Helium go this way and neon go this way, and both sit on a detector, or both are placed on a detector, and it gives you the weight. Okay. Again, I am mentioning that this is not this is just a very, very crude picture. We will be discussing each thing step by step. Okay, so you got a spectrum. Wow, this is M by G of, you have this number of atom of neons and this atom of helium. So this you got a spectrum of helium and neon. So we really don't know anything about the mass spectrometer, but what I am giving you is just a simple picture, that what actually happens in a mass spectrometer. And believe me, we will be studying each step in great detail, because each step is very, very important, and it will take a much longer time to explain. So as I told you, as I already mentioned, that that the mass spectrometry can give us the mass. I am not going to say that it gives us the atomic weight right now. It gives us the mass, and we did 2 examples. One example of the lithium and the neon plus ion, and we got a crude type of a spectra in which x-axis has M by G, and the y-axis has signal intensity. Okay, now let me go further a step further to explain something else, or to start discussing something else, or mentioning it for the first time. So the spectrometric techniques, it is classified by different scientists in different ways. We will classify it on the basis of ionization. Okay, that there are two methods. One is method of ionization. One is called as the hard ionization, and the other one is called as the soft ionization. Both the techniques which we will be studying, we haven't started the mass spectrometry as yet. Okay, we just saw the spectrum. So in both of these techniques, the hard ionization technique and the soft ionization techniques, they are greatly different from each other, and they have different purposes. So for some purposes, the hard technique is used, and for the other purpose, the soft ionization technique is used. Okay, so suppose it's again an example, and really don't worry to see those examples, because these will be you will be understanding those examples, that what actually I am writing it in 5, 6, 7 or 8 lecture after. Let's see this example. I am doing this example intentionally to make you people understand that what these small terminologies means. It's now just to explain the terminology. What is hard and soft ionization techniques? So let's see first the soft ionization technique. What a soft ionization technique means, okay, which we will be discussing. First of all, I want that you people should think something that what it is, or some sort of sketch develop in your mind. Soft ionization technique, it will be clear from by an example. Let me give you an example. It has a weight of 74, I think. 74, 12, 48, 74. It has a mass of 74 if you count hydrogens, because as like 1, 2, 3, 4, 4 hydrogens. Sorry, 4 carbons, 1, 2, 3, 4, plus 3, 3, 6, 9, 10 hydrogens, plus 1 oxygen. So carbon is 12, hydrogen is 1, multiplied by 10, multiplied by 4, and plus 1 multiplied by oxygen. So 1 multiplied by 16. It will give us result of 74. But what is soft ionization technique mean? Soft ionization technique mean if you get this molecule and you place it somehow magically in this mass spectrometer. We don't know how to inject them, because we even haven't started studying the inlet, that how to feed a sample into a mass spectrometer. Suppose you go and just feed this molecule into the mass spectrometer. What will be its result? It's 74, you know. So it will become plus 1 charge, the whole molecule. How? We will be discussing it, don't worry. So it will be plus 1, so 74 divided by 1 is equal to 74. Okay, so the mass spectrometer will give us a peak or big peak at 74. This is an analogy to the soft ionization technique, that this will happen in soft ionization technique. It will give us the molar mass. Molar mass means the molecular mass, the 74 mass. Okay, and SAM, M by Z, or signals. You get a spectrum. But what about if you place, this is in soft ionization technique, which we will be discussing. It is not that simple. Okay, now if you want to place this molecule in a mass spectrometer which utilizes hard ionization technique, what will happen? Again, so it will not give 70 any peak on 74. It will give a small it will give a big peak on 59. M by G 59. This is signal. So it will drag us crazy that we placed something in the in the mass spectrometer which we knew the mass, its mass was 74 and it gave us 59. Either the machine is crazy or we people are crazy or we people are unable to understand this thing. And this thing, the soft ionization technique, give us the right result. But both of the results are right. Both the results are absolutely correct. But both the techniques have some different uses. Okay, under different requirements, different techniques are used. Because our aim in this course is to determine the structure of a compound. Okay, or in coordination with other spectrometric techniques. So now you have studied this, that there are two. Okay, so it's a bit clear that there are two techniques. One is soft ionization and the other is the hard ionization method. Both of the methods, there are various methods for soft ionization techniques, and there is one which is well known, and it is for the hard ionization techniques. So for hard ionization technique, we have I am just writing the abbreviations of those things because I lost 4 to 5 batteries within half an hour and I am changing that. So the hard ionization technique, it is EI. It's just abbreviation of electron ionization. And for soft, it is ESI. Electrospray ionization, FAB, fast atomic bombardment, MALDI, matrix assisted laser desorption, etc., etc. Okay, so I just wrote the electron ionization and these abbreviations because of the battery loss, and you know that the country is locked down. Now, what we have studied, we haven't studied anything as yet. We just familiarize ourselves with some terminologies. We just saw that what is the basic principle. From tomorrow or in the next lecture, we will be start studying the first hard technique, electron ionization, in great detail. That what it is its principle, and how it is used, and what are its results. So it will take 6, 7 or 8 lectures or even more to understand those things. So don't worry. What I just mentioned in today's lecture is the whole course. It's the whole course, almost the whole course, which I just introduce you people to, and we will be studying electron ionization, and after that we will be studying ESI, FAB and MALDI, and there is another one which is chemical ionization after we finish the electron ionization. Okay, thank you.